So good morning, everyone. In today's presentation, we, the Group 3, will report the types of chemical reaction and the factors affecting the rates of chemical reaction. First, in this presentation, we will going to present the 4 types of chemical reaction. First, we have the direct union or combination. Second, the decomposition. Third, the single displacement. And fourth, double displacement. First, we have the direct union or combination. It's one of the most types of chemical reaction. Second, the decomposition, the breakdown or change of a material or substance by heat, chemical reaction, or other processes into other displacement. Example for this is that AB is equals to A plus B. And third, we have the single displacement. When an element replaces another element in a compound. So when A reaction reacts with B plus C, A is a pure element, reacts with compound BC. So typically A is going to pair with either B or C. So if it pairs with C, it is going to kick out of the solution and B will be pure element. And lastly, we have double displacement. Double displacement reaction typically result in the formation of a product that in precipitate. So for example, AB plus CD is equals to AD plus BC.
The factors that can affect reaction rates are surface area of a solid reactant, concentration or pressure of a reactant, temperature, nature of the reactants, last, presence or absence of a catalyst.
So the learning outcomes, the student should have observed some types of reactions, identified the products of these reactions, identified, excuse me, the different factors that affects the rate of chemical reaction.
The materials needed are 19 test tubes, 10 ml graduated cylinder, test tube rocks, spatula, alcohol lamp, test tube brush, test tube holder, crucible tongue, beaker, iron stand, thermometer, dropper, rubber tubing, wire gauze, and iron ring.
Reagents of magnesium ribbon, CaCO3 calcium carbonate, 1 mole of CuSO4 copper sulfate, staple wire, 1 mole FeSO4 ferrous sulfate, Cu wire, copper wire, 3 moles of HCl or hydrochloric acid, 1 mole 1 mole Pb, NO32 lead nitrate, 1 mole of K2CrO4, which is potassium chromate, 0.5 mole of H2SO4 sulfuric acid, 0.5 mole of BaCl2, which is barium chloride, and 12 NHCl hydrochloric acid, mossy zinc, 6N-HCl hydrochloric acid, disodium phosphate, 3N-HCl or hydrochloric acid, K-permanganate, manganese dioxide, BaCl2, barium chloride, Mg mixture or magnesium mixture, Zn dust or zinc dust, sodium oxalate, and H2O2, which is hydrogen peroxide.
Okay, so now let's just proceed to the procedures. But first, when we say procedures, it's simply referring to a particular way in accomplishing something. So here in our procedures, we have a letter B, which is the factors affecting the rate of chemical reaction. When we say, oy, wait lang. Di ba meron pa hello? Crystal?
Mm.
Guys, yung kay Ralph, yung kay Ralph. Uy, bakit ganito?
Wait lang, down na lang sa
Sige, continue lang. I-cut na lang ni. Continue lang.
Our procedure, we have a letter which is the factors affecting the reaction. So when we say procedure, it's simply our influence. Then this junction of our topic, we must affect the rate of chemical
Concentration of reactants. A is 5 ml of each concentration of HCl or hydrogen chloride in separate test tube. B. Add a piece of Mg ribbon to each test tube. Temperature. Place 10 ml 0.1 m sodium oxalate solution to each test tube. B. After that, leave test tube 1 at the room temperature and test tube 2 at the 75 Celsius. After that, after heating, treat each tube with 10 ml potassium permanganate acidified a few drops of dilute sulfuric acid.
4. Effect of surface area on reaction rates. A. Place 5 milliliter 3 molar of hydrochloric acid to each test tube. B. Drop mostly zinc to test tube 1 and add a pinch of zinc dust into test tube 2. 5. Presence of a catalyst. A. Into two separate test tube, add 2 milliliter of hydrogen peroxide to each tube. B. Add a pinch of manganese dioxide to one test tube and compare.
Thank you for listening. So that is our presentation, the group 3.